Hi guys, welcome back to TBS Skylabs. So we're going to continue talking about these little black fellows. Use my pen instead, it's easier. These little black fellows here that are called... Oh, why is that working? Interesting. That are called transistors. Unlike this greedy black fellow here, who's called Lucifer. Would you like a snack, Lucifer? Speak! 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 Wait, and then this little terror is also called Harley. There we go. Okay, anyway, so these little black bits here are called transistors. And what happens with the transistor is the power, or the current, can flow through here. And if the transistor is off, let's say, then nothing can flow through the rest of the circuit and back to the negative. Okay, so we've broken the circuit. The way that we turn on the power, the way that we turn on the transistor, is to provide a small amount of current via usually quite a big resistor in order to stop things being overpowered. Okay, so let's try. Yay! Okay, so I'm opening the transistor, and notice the power is not flowing from here. The power is flowing from here when I turn on the transistor. Maybe I get a bit from here, but generally speaking, this bit here is where the full voltage is coming from, or the full current. Now that might seem a bit, well, frankly, pointless. I mean, you get a 1, you get out a 1. What's the point in that? And you might be right. So what we're going to look at today is how we can adapt our little transistors here and try and make something a bit slightly more useful. Okay, so let's think about it. Now, hopefully some of you are vaguely familiar, at least, with Scratch. Okay, so it's actually really hard to sort of control a screen and a keyboard at the same time, and a phone at the same time. Okay, so hopefully most of you can work out what this code generally does. So I have a variable called that has the details or the value TBS, and I'm saying if the name variable equals TBS, not. So if the name is not equal to TBS, then say I don't know you. Otherwise, say welcome TBS. TBS, by the way, is the name of my school, the British School of Kathmandu. Yay! Hopefully, this whole idea of a not, so taking the opposite of what we expect as the value, is going to be reasonably okay with most people. Those of you who are more familiar with Python, maybe you have something like this. So name equals TBS Skylabs. If name, and now exclamation mark equals in Python means not equals to. So if the name is not equal to TBS Skylabs, then print, who are you? Otherwise, print, welcome to TBS Skylabs. So what we want to do is we want to try and convert our little circuit here, and I guess this is the whole point in the course, is to try and see how, like, say, programming and all this other stuff relates to the physical electricity on a board. So we need to convert this into something that is going to, well, let's draw it out a little bit. So the first time we had what was called a buffer, I believe. 1 would go in to the buffer. Now a buffer is just going to be represented by a little triangle, and we would get out a 1. Now on the other hand, if we put in a 0 to a standard buffer, we get out a 0. Hey, exciting, pointless, possibly, but still. Anyway, so what we want to do is we want to instead make a NOT gate. Now that looks just like a symbol for a buffer, but it's got this little 0 at the front, or little O at the front. And this generally means negate something inside of our circuitry. So if I put in a 1, I'm expecting out a 0. And this is, sorry, just to be clear, this is for a NOT. Whereas if I put in a 0, I'm expecting out a 1. Okay, so see how we're getting out the opposite of what we put in. And the place where we're going to put it in is going to be to the base of the transistor. So how could we change this setup so that it's going to go into, so that we're going to get this NOT gate application out? Well, let's have a look. Now, getting us to go into my stand has always been a bit of a pain, but hopefully, yay, good. All right, so I'm just going to detach my again, I should probably disengage the power. Sorry, again, I'm really bad for that. Please tell me off in videos when I just leave the power plugged in, because nobody wants to get electrocuted later. Trust me, it's sore. So at the moment I've got this going into here and coming out. Now what I want to do is get my first state. Now my first state says that when there's a 0 going in, which there presently is, then I should get a 1 out, which means my light bulb, my little LED, should be lit up. Okay, so how do I do that? Well, I mean, that's pretty easy. I almost have to just completely disregard that bit, plug my LED into here, and plug the resistor into the other leg of the LED. Okay, or you know, we could go through that resistor first. We wanted to switch it up a bit, so I'm just doing this because I want to show you a diagram later, and I'd like it to be the same as the diagram. Okay, so I've got that going into there, going into the resistor, and then I'm going to have that. Sorry, this board is still a bit rubbish, guys. So stiff. I'm going to have that connecting. Get some stabby bits. I'm going to have that connecting into the other bit here. Okay. So, sorry, I just wanted to match up with a diagram. I'm going to show you in a wee bit. Okay. So, look at this resistor. It goes into here. Maybe. I hope. There we go. And this resistor goes into here. Yay, that's a bit better this time. Okay, so the power is just going to go along there, and then I'm going to use the, again, this side is doing nothing. Just completely remove that. This side is going to go from the positive into the negative. Oops. It's going to go from the positive into the negative. Maybe. There we go. Okay, and then finally I want to connect that down into my ground, or into the ground, rather, my ground. I don't own it. Oops. The same problems. Okay, and connect that from here. Fingers crossed. It's a bit stiff still, but into the ground on the other side. Okay, and that should make, maybe, if it's connected right, thing should light up, which it's not, which means I've got problems. Okay, so let's see if I can find out where this problem is. It's probably this wire here. And I just knocked off my video thingy. Okay, let's try again. Okay, maybe. Okay, so, oh, do you know what I did? I just didn't plug in the power because I'm a complete and utter idiot. Right, okay, so then let's go from the negative side into this bit here, and this time if I'm not an idiot and I turn on the power, it won't work either. Oh god, okay, what's going wrong? This system is not working. Okay, let's make sure everything's in the right place. Make sure my big leg of the LED is connecting into the power. Make sure my resistor is working. I think probably the issue, oh there we go, it just seems like my resistor wasn't, it's got this stupid breadboard. There we go. Okay, my resistor maybe wasn't quite stabbed into the breadboard quite as thoroughly as I wanted it to be. However, for now the power is going from here through the resistor into the LED and then out to the ground, and that could be in better, but I think it's going to work. Okay, so what we want to do instead is make like a little trap door. Okay, so think about this. If we had some power flowing this way and it was going into, let's call it an LED over here. I don't know why that's an LED. It's not an LED, it's more like a padlock or something. But imagine instead of the power being able to flow into our LED here, imagine I could take it on a diversion and get it to the ground faster than going through the LED. So effectively I'm opening a trap door here, opening a trap door and letting the power just like drop out rather than going into the whatever this is, I'm assuming LED here, that's a bit messy, and going into the ground that way. Okay, so is there a way that we could add in our transistor to allow us to do that? And the answer is, of course, yes. Hopefully. So what we want to do is we want to, let's do it here. Again, I just want to do it exactly as we've got it in the example diagram that we're going to use in a bit. Now I need to move things a little bit forwards just in order to make some space for my transistor, but everything else should be the same. Okay, so I've moved it forward a little bit for the purposes of moving stuff around. So I am going to connect my right leg, let me turn this off so you guys can see better. I'm going to attach this right leg into the same row as the resistor and the left leg of the LED. Now the purpose of this is to give the give it another possible road that it can go down. Okay, again I'm going to have to move things forward again because it's so messy. Okay. Sorry, I should plan these things out ahead, but I didn't, so boo me. Okay, so get that in there. I move my LED forwards one row, just for the sake of moving it forwards, because I can get more tidy. And then into here. Okay, so hopefully you guys can maybe see that there. I'm not sure how clear it is, but you can see that the resistor, so I'll use the pen. You can see that the resistor, the positive leg of the LED, and the collector, anyway the left leg, if facing the flat bit, of the transistor are all now connected together. Now what I want to do is, this power is going to flow through there, hopefully still, yay, okay, so the power is still flowing through there, but I want to give it the opportunity of going from here to the ground without having to go through the resistor. Now in theory, that is going to mean that it has an easier path to get to the ground. I may be wrong. Okay, so that's, oh my god, rubbish breadboard. I'm going to connect that into the ground. Now I could connect it into the same side, I could connect it into a different side. The important thing is that it is connected. Let's try it over here first. Okay, again just to show you, still nothing has happened. Okay, but I know this wire's getting in the way of the video, but that's just going from there straight to the ground. But if I were to reintroduce my button over here, okay, and the button is going to take power from the power positive rail. When I press it, it's going to pass it through this slightly bigger resistor, and that's going to go into the base of the transistor, if I can get it in. I think that's probably enough. Okay, now, so basically, when I turn on the switch, good. So when I turn on the switch, which is going to send a small current to the middle leg of the transistor, the middle leg of the transistor is then going to open and allow the power to flow directly to the ground, rather than going through the LED. Okay, so like I said, it's sort of like this over here, where the power was going to the LED, but instead we've opened an easier route, and so all the current is now being directed through this other route. Again, just to show you, so our current is going into the middle line of the transistor, and that's going to open up a gateway through this big black line that keeps getting in the way of the video into our into our ground over here, and that means the electricity can flow without flowing into the LED. So we've made a different route that it can get through. Okay. Now maybe it's better. Now Lucifer's now being a test.